Chapter 10, Number 14. The angular speed of a propeller on a boat increases with constant acceleration from 11 radians per second to 39 radians per second in 3.0 revolutions. What is the angular acceleration of the propeller? So let's start identifying the things we have here. We have this, which is omega initial, 11 radians per second. And we have this, which is omega final, in 39 radians per second. And then maybe least obviously, but we have this, and this is a delta theta. Although it's in revolutions, not radians, but we can fix that later. What we don't have is any information on t. And what we're looking for is, of course, we're looking for the angular acceleration, so we're looking for alpha. So we look at our formula sheets and we try and find one that doesn't have a t in it, and that's the usual kind of omega final squared is omega initial squared plus 2 alpha delta theta, which is the analog to that v final squared is v initial squared plus 2a delta x. Just as a reminder that we have that from chapter 2, and its analog is this. So what we're looking here is we're going to take this equation and solve it for alpha, and it's going to give us omega final squared minus omega initial squared over 2 delta theta. And we're going to say, well, that's 39 radians per second quantity squared minus 11 radians per second quantity squared over 2 times 3.0 rev, but then I need to convert that there are 2 pi radians in every revolution. And now we can go through and just get the numbers. Turns out to be 37.136 radians per second squared, which, since we have 2 sig figs, is really just 37 radians per second.